Let's talk about our next topic, which is Transmission Control Protocol. So Transmission Control Protocol, TCP, is a reliable connection-oriented protocol that ensures data is delivered accurately and in order. It breaks data into packets, checks for errors, and resends any lost packets. Connection-oriented transfer protocol. It ensures reliable data delivery by establishing a dedicated path before transmission. For example, TCP. Establish connection. It uses a handshake like SYN, ACK, and ACK to set up a session before data transfer. It also assigns each package sequence number. It labels data packets for orderly reassembly at the receiver. ACK, which we call acknowledge. It allows the receiver to acknowledge. Receiver confirms the successful packet delivery. NACK, which is negative acknowledge, where the receiver requests transmission of missing or corrupt packets. It also allows the graceful termination of a session that closes the connection properly, that is FIN-ACK, to avoid the data loss. TCP-based application protocol, which is Hypertext Transfer Protocol Secure, that is HTTPS. HTTPS is the secure web browsing. It uses port number 443, where SSH, that is secure shell, it is the encrypted remote access. It uses port number 22. User datagram protocol. User datagram protocol is the UDP, is a fast and connectionless protocol that sends data without guarantee. So no handshakes or error recovery or packet ordering. It is ideal for real-time applications like video calls or gaming, where speed matters more than perfection. It is a connectionless and unreliable delivery. UDP-based application protocol, as I said, it is a dynamic host configuration protocol, DHCP. It uses trivial file transfer protocol, that is TFTP. Now, we understand about the well-known ports. What are the various ports that we know? In networking, there is DNS, that translates that domain names to IPs, like UDP by 53 for queries, TCP by 53 for the large data. DHCP, it assigns the IP automatically, UDP 67 or 68 for server client communication. NBT, that is net bias for file printing and sharing. It uses UDP by TCP from 137 to 139. SNMP. It monitors the network with UDP 161 for queries and 162 for alerts. LDAP, which manages the directory services. TCP 389, remote access. Remote access, it is SSH, secure remote login. It uses TCP 22. LNet, unsecure remote login. It uses TCP 23. RDP is the remote desktop control that uses TCP 3389. File transfer. File transfers, that is TCP 20 or 21 in FTP. HTTP uses TCP 80. For HTTP, 443 for encrypted HTTPS. SMP for file sharing, it uses TCP for file. Email. SMTP to sending the mail, it uses TCP 25. POP3 uses TCP 110. And IMAP, it uses TCP 143. Now, we'll understand about the Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, that is DHCP, automatically assigns IP addresses to device on a network, so you don't have to set them up manually. It also provides details like the subnet mask, gateway, and DNS server, making network setup plug and play. You can see in this diagram, it shows 4-step DHCP process for device MAC AA getting an IP address. DHCP discover. It device broadcast DHCP discover to find a DHCP server. Here you can see that. Okay. The server responds DHCP offer with an IP of 192.168.1.101. Then the request. The device asks DHCPR request to confirm the offered IP and then acknowledge. The server finalizes DHCPAC, the lease, the assigning IP and settings gateway submask. Now we'll understand about the domain name system. So what is domain name system? Domain name system DNS is like a phone book for the internet, translating easy to remember domain names, for example, google.com, into IP addresses, for example, 142.250.190.46, so device can get connected. It works in the background every time you visit a website using a network of servers to quickly find the correct IP. If there is no DNS, that means typing numbers instead of names.